Hello, my name is Sandra Garneau, and this is my Project 3 for my Design and Manufacture class at the Georgia Institute of Technology, and this is in the semester of fall 2024. As a brief project description, in this project we are tasked to discuss certain things on 5 topics that we have learned in the course so far. And these things that we're supposed to discuss are the summary and applications of said topic, as well as the importance and or interest as to why we chose those topics out of all of the ones that we've discussed in class. So the topics that I chose are injection molding, sheet metal shearing, sustainable manufacturing, extrusion, and hexpod machines. The first one of my topics is injection molding. So injection molding is essentially a process where molten plastic is injected into a mold and then left to solidify. This is super useful for mass-produced products that are made of plastics, and it's especially useful for complex geometries, as it's just the mold that has to fit the part. There are 6 steps in injection molding. Those 6 steps are clamping, injection, dwelling, cooling, mold opening, and removal. As you can see in this little GIF here, you can see kind of how that works. You can see the plastic going into the mold, and then it opening and removing that red little piece. So the reason I chose injection molding and its importance and my interest in it is because it's super, super common when you're talking about manufacturing plastic components, especially mass producing. Additionally, it is efficient, it's cost effective, it's super versatile as far as, once again, producing lots and lots of parts with complex geometries. You have to make the mold once, but once you have that, you can just make a whole bunch, and then you're just paying for the use of energy and the material and labor. But overall, it's super cost effective, super fast, can be used for so many different parts as well. And so that's why I chose injection molding. The next topic I chose was sheet metal shearing, also known as sheet metal cutting. In essence, this is how sheet metal is cut into its various different shapes that it's used for in manufacturing. To do this, 2 tools are used, either a punch and a die, or upper and lower blades. Essentially what happens is the bottom part, or the support, supports the metal, the sheet metal plate. The top part, or the punch, will go down on the part that is not being kept of the sheet metal, with some clearance between the two. And so essentially that pushing force, as you can kind of see in this one here, this, as it goes down, this is essentially pushing up. That's causing a lot of shear right there, which essentially causes it to break. So you can see right here, it's kind of just where it breaks. When that does happen, it is not a perfect edge, as you can see in this little picture here. There is a burr at the end. There's also a fracture angle. And the depth of all of these things, the fracture depth, the burnish depth, the rollover depth, etc., those are all determined on a couple different things, including the sheet metal thickness, the blade sharpness, etc. So the main reason that I chose sheet metal shearing and why I found it interesting is actually from the TV show How It's Made, something that I used to watch a lot when I was a kid, and I always found it super interesting. And there was a lot of different end products that used sheet metal. And so I had seen that process of sheet metal shearing with the punch and the die many times. I had always assumed that it was a nice clean cut on the edge. And so when I had learned that it wasn't in this course, I found that super interesting. So I did want to do a little bit more research on it, and I found it super, super cool. My next chosen topic is sustainable manufacturing. Essentially, sustainable manufacturing is are manufacturing processes that aim to lower negative impacts on the environment, economy, and society. It is defined as the creation of manufactured products through economically sound processes that minimize negative environmental impacts while conserving energy and natural resources. And that is from the U.S. Environmental Protection Agency. In addition, sustainable manufacturing generally is a goal of reducing waste and consumption, as well as increasing worker safety, and a couple of other things. The reason why I found this interesting and that it's important is that manufacturing is super vital to the way that we live now. And so making that more sustainable means that we can continue doing that for longer. And it's essentially preparing us for the future, which is really important. Similarly, this is why I found it very interesting. I've always been really interested in sustainability and climate change, also in economics. So I think that in engineering, using sustainability practices in manufacturing is really important. So I really enjoyed doing a little bit more research on this topic. The next topic that I have chosen is extrusion. Essentially how extrusion works is that a billet or an ingot, which is essentially the raw material, gets heated most of the time and then pressed through a die with a ram. This is super useful for products that have complex but continuous cross-sections. So if you look at the photo that I have here, the cross-sections on these bars aren't super simple, but they are continuous along the entire length of that bar. And so that's what makes these parts really easy to manufacture using extrusion. There are multiple subtypes of extrusion, including hot extrusion, cold extrusion, direct and indirect extrusion, and hydrostatic extrusion. Hot and cold are referring to the temperature of the billet or ingot. In hot, it is hot, and cold, it's cold. Some of the advantages of hot extrusion are that it's less force required, and it's easier to work with. However, there's more wear on the die that gets used. With cold extrusion, you do end up with using a lot more force, but you end up with higher mechanical properties and a better surface finish in your final product. Direct and indirect extrusion refer to the flow of the metal in the feed. So in direct extrusion, it is in the direction of feed of the punch, and in indirect extrusion, it is the opposite. Hydrostatic extrusion is when fluid is used in a container to essentially help to apply pressure on the metal. And so this is helpful in that there's less friction that is happening. So the importance and my interest in extrusion is that it is a fundamental machining process. It is used in so many different types of products. One thing that I remember was a class that I had, and there was a whiteboard, and there was that silver thing underneath that is used to hold the markers. And I remember a professor just telling me that is something that in real life would be extruded. And so that just is something that stuck with me. There's also a picture here kind of showing how exactly direct extrusion works. So this is the ram. This puts pressure onto the billet or ingot, which is right here. And then this is the die, and it comes out with whatever that cross-section of the die is. The final topic that I have chosen is hexapod machines. These machines are similar to like a CNC router in that they can machine materials and they have many degrees of freedom. Specifically, hexapod machines have 6 degrees of freedom, meaning that they can machine materials without needing to take out the workpiece and remeasure and resecure it, which is super useful. These machines can also be portable. I will say that they're not the best choice for mass production, but they are also smaller in size than machining centers. I found this topic really interesting for many reasons, but specifically the fact that this machine can be relatively easily portable is really interesting. I also found it really interesting that machining centers can be converted to hexapod machines with certain attachments. As far as importance, these machines have a lot of versatility, which is super useful. I also picked this topic because I have done some machining before, and taking out the workpiece and resecuring it and remeasuring it takes so long, so the fact that this has so many degrees of freedom was super interesting to me. Finally, here are the resources that I used in creation of this project. And as a disclaimer, this video was created for educational purposes only. Thank you.